compounds in formulas is what we're going to talk about with getting connected. We're going to review simple ions, which we did in our warm-up. We're going to write formulas for ionic compounds and also name the ionic compounds. So take these down for the objectives. So this is what we talked about in our warm-up. Remember, metals, which are on the left side of the periodic table, form positive ions. Non-metals, on the right side, they form negative ions. And the charge is based on how many electrons they have to gain for non-metals and lose for metals. So magnesium is going to lose 2 to form a positive 2 charge. Okay. Sodium, where's my mouse? Sodium has to lose 1 to form a positive 1 charge. Aluminum has to lose 3 to form a positive 3 charge, to be like neon. We talked about this in noble gas envy. Oxygen has to gain 2 to have a negative 2 charge. Phosphide has to gain 3 to have a negative 3 charge. Okay? So what we did in our warm-up, we should be pretty good at this. Ionic compounds. This is big, and this is really important. Positively and negatively charged particles attract each other, because positive attracts negative. They form in a ratio, so the compound has a total charge of 0. These are 2 important concepts here. Moving forward. So aluminum, don't copy this down, just pay attention. Look up here. So aluminum has a +3 charge. Sulfide has a -2 charge. It's because of what we talked about. Aluminum loses 3 electrons. Sulfur gains 2. So what happens is we have to form a ratio to cancel out the positive and negative charge. So for +3s to cancel out +2s, we need 2 +3s to cancel 3 -2s. So what happens is you have a formula Al2S3. Okay? That's aluminum sulfide. So write this down. Write the first 2 down. And then we don't have to write the third one. Okay? So, for example, we have sodium chloride. So you guys can look in your ion list. See that sodium is the +1 charge. Na+1 is the formula. Chloride is a -1 charge. Cl- is the formula. So those charges are equal and opposite charges. So +1 and -1. So all we need is 1 Na and 1 Cl. Same thing for calcium sulfide. The calcium ion's +2. Sulfide ion's -2. So calcium sulfide, we need 1 of each. CaS. Last one, aluminum nitride. Aluminum +3 charge. Nitride -3 charge. So the formula for aluminum nitride is just Aln. So those are the easiest ones. So if they have the same but opposite charges, +3, -3, +2, -2, +1, -1, they just have 1 of each. They come together in that way. That's why table salt is NaCl. What if the charges aren't equal? So we'll talk about this one, okay? So, all right. So we have to form in a ratio to cancel out the total charge, like the aluminum sulfide we talked about before. So, for example, calcium chloride. You guys look in your ion list. Calcium is +2. Chloride is -1. So we need 2 -1 charges to cancel out 1 +2. So we need 2 Cl's for 1 Ca. Okay? Next example, calcium nitride. Calcium +2, nitride -3. So we have to form in a ratio to cancel this out. So what happens is you're going to need 3 +2s to cancel out 2 -3s. So you have Ca3N2. The last one we're going to talk about, tin 4 sulfide. Tin 4 is Sn+4. Sulfide is S-2. So tin 4 sulfide is SNS2 because two negative 2's will cancel out a positive 4. So that's what you want to do. You want to always make sure that you put it in a way that it cancels. What do we do if we have polyatomics? So take this down. You can take down the nitrate example and the ammonium example, and just look at sulfate and phosphate. Okay, so I'll pause it for a sec. So a polyatomic ion is just groups of ions with charge. So an example one is nitrate. One N and three O's come together, and they have a -1 charge. Sulfate's another one. The 5 atoms together charge a -2. The 1 S and the 4 O's. Can also have a positive charge, like ammonium. The whole group has 5 atoms, the N and 4 H's, but a +1 charge. All right? Moving on. The same rules apply. But the whole idea of they form in a ratio to cancel out the total charge. But if you need more than one polyatomic ion, you need to put it in parentheses. Okay? So get this down, and then we're going to do some examples. So the whole idea of this one is that calcium nitrate, for instance, calcium is Ca+2. Nitrate, not chloride, I made an error in there, is NO3 -1. So you need two -1 charges to cancel out the +2. But since nitrate is a polyatomic, you need to put parentheses around the whole NO3 group and put the 2 outside. Okay? So that's pretty much it for notes. All right. So guys, let's go over this first one. All right. Uh-oh. Okay. Sodium sulfate. Sodium is Na+. Has to be capital N lowercase a. That's what sodium is. You have a list. Okay? Sulfate is SO4 -2. Capital S, capital O, subscript 4, -2 is the charge. So to balance this out, what do we need to do? We have a +1 charge here and a -2 charge here. So what do we need more of to cancel this out?
You need more of the Na.
I need more of the Na. So let's add one more. Am I canceled out yet with charge? Yeah. +1 -2 total is what?
Oh, so that's it?
0. So now I need to make my formula. So how many NAs do I have?
You have 2 Nas.
I have 2 NAs. So I have Na2. And then how many SO4s?
0. -2.
I have one group of this, right?
4.
SO4. One group of SO4. Okay, so the formula is Na2SO4. So you guys, I want you guys to do the rest. Okay, right now. Yep. I'm going to go over aluminum nitrate, guys. So aluminum is Al +3. Nitrate is NO, capital, it's each NO3 -1. So you guys should easily be able to do this. Do they cancel out?
No.
No. So what do I need more of? Which one? Negatives. So let's add another one. NO3 -1. Do I cancel out yet?
No.
No.
One more.
Need one more. NO3 -1. So now, have I canceled it out?
Yes.
How many ALs do I have?
One.
So I have AL. I have one AL, so I write AL. How many NO3s do I have?
3.
So I have NO3. I have 3 of these. Since there's more than one atom here in the group, I have to put it in parentheses. So I have AL, NO3, 3. All right? So that's it. I'm in the notes now. Write these down. Write in your homework. Finish the rest of these ones.
done?